Hi, today we're going to look at solving multivariable linear systems, meaning in this case we're going to be using three variables. And in order to solve a system that has three variables, instead of having two equations, you're going to have three equations. And so sometimes they'll give you some nice easy ones, sometimes a little bit more complex. Let's start with an easier one. And what makes this one easier is that in this second equation right here, they actually tell you y is equal to 2. So you don't have to do a lot of work to find that variable, they just tell it to you. And what you can do is grab that 2 and plug it in for y in that third equation. And I'm choosing that because that third equation is pretty simple. There's only two variables in it, so when you plug in the 2 for the y, you can pretty quickly then go find what z is. So in this case, I got z to be a -2. All right, so we've got z figured out, y they gave us, and then you just take those two and plug them in for z and y in the top equation so that we could go figure out what x is. So plus 2 goes in for y. You got a -3 times a -2 is going to be a +6. All right, that's 8 that I'm going to move to the other side there. So 2x is equal to 2, so x is 1. Okay. So the way that you answer these is not as an ordered pair, but as an ordered triple. Okay, so if you think of an ordered pair, that is the point where the two the two equations, whatever they are, end up intersecting on a graph. Well, if you're dealing with three variables, it's not really on a nice xy coordinate plane because you have this z variable in here. So what that actually is a three-dimensional situation. So you have an x and y plane, but you also have a z plane that shows you the depth that you have. So you go left, right, you go up, down, and the z gives you some depth. So this equation right here, this original one that we had, isn't actually a line. What it ends up being is a plane. And so when you have three of these equations, you're looking for, and these are not all three variables, so they wouldn't all be planes, but if you had one, and we'll do some, it's where the three planes intersect. And it's a particular point. We call that an ordered triple. Okay, let's try one that's a little harder. Here's an equation. The top two have three variables. The bottom one only has two. And so what I have to do when I start dealing with systems of three variables, I'm going to have to kind of do the work twice. What I have to do is I have to pair up two of the equations, get it down to two variables, pair up a different two equations, and get rid of the same variables so that then you'll end up with two equations with two variables, and then you're back to what we've been doing. So let me show you an example on this one. This third equation only has two variables in it. It has an x and a z. So what I'm going to do is I'm going to group these other two equations up here, and I'm going to get rid of the y that's in those two equations. So I'm going to solve that system. And if you look at it, the y's are going to drop off beautifully anyway. So what I'm going to do is go ahead and combine them together. I've got an x and a 2x gets me a 3x. The y's would cancel out. And then I have a z and a z that gets me a 2z. 6 and 3 is a 9. Okay, so I've combined the first two equations to get this equation that has an x and a z. Plus I have this equation here that has an x and a z. So I'm just going to solve the system of those two equations. So I've got this 3x minus z equals 0. I got a 3x plus 2z equals 9. And look at how you can solve this system. Probably the quickest thing to do would be just go ahead and go change the signs in one of them so that you'll have a -3, and then it doesn't affect your 0. But by doing that, my 3's will cancel. And so then I have 3z equals 9. So z is 3. And I've got my first variable figured out. And then where do you plug that back in? Well, I would plug it back into this third equation because it only has an x and a z. So let's type in or write 3x minus, instead of putting a z, we're going to put our 3 in there, and then go solve. So x is equal to 1. And then the last one we have to find is y, and I can plug it back into the top equation or the second equation. The top one looks pretty easy. Let's just do that. You'd have 1 plus y plus 3 equals 6. So that ends up with a 4 on the left side when you combine those like terms. So y would equal 2. And then I'll come back and answer this as an ordered triple. And you always do x comma y comma z. So it'd be 1 comma 2 comma 3. All right, here we go. This one's the full-fledged, all three equations have all three variables. So you're going to pair up a couple of them and see if you can get something to eliminate. I think I'm going to work on, I think I'm going to do the y's. Okay. To get my y's to eliminate, I'm going to go ahead and choose to group these top two equations together, and I'm going to get that top equation to have a 2y. So I'm going to take the top one times 2. So that'll get a negative 10x plus 2y plus 6z equals 50. Okay, in the second equation, I'm just going to rewrite it. So negative 2x. There's the y's that are going to drop for me. I get negative 12x plus 8z equals 56. Then I have to grab a different set of equations and try to eliminate that same variable. So I'm going to try to get rid of my y again. I'm going to choose to group the last two. Doesn't really matter, you just pick what works for you. If I try to drop the y there, I'm going to take that top equation, or that second equation is what it is, and take it times negative 3. And so then I'll end up with a negative 6x. Actually, let me rewrite that so it's kind of separated. All right, so take that second equation times negative 3 gets you a negative, just times a positive 3, but I'll get a negative 6x and a negative 6y. Oh, I lied. Sorry, let's go back. Yes, I'm going to take it times, I need one of those y's to be a positive. So I'm going to take that second equation times negative 3. So then I'm going to have a positive 6x, and then a positive 6y, and then a negative 6z equals a negative 18. Combine that with the bottom equation without having to change it. Y's drop off. I get 10x minus 4z equals negative 48. And what I've accomplished here is to get two equations that use the same two variables, x and z. So then my next job is to take those two equations and solve the system of equations with those. So looking at those, I think I'm going to leave the top equation by it alone and just leave it the same. And then the bottom equation, I'm going to take times 2. What I see happening here is being able to get rid of the z. Okay, and so then I end up with an 8x equals a negative 40. And so that'll come out really nice for us. X is negative 5. And then once you find one variable, you're just substituting back into other equations. It doesn't really matter which one. I'm going to take this and just plug it in right here just to make life simple. And so I'm going to end up with a negative 50 minus 4z equals negative 48. Add the 50 to the other side. Which is going to get me a 2. And that does end up a fraction, but that's okay. That's not bad. you're going to definitely get some fractions today. So z is equal to -1/2. So you got your x, you got your z, then you plug it back into the original to figure out what your y is going to be. I think I'm going to go ahead and use that second equation. And so we're going to plug our x and our z into this equation and go find y. So here we go. We got a -2 times a -5, so that'll be a 10. And then I don't know the y. I'm going to plug -1/2 times 2. That's a -1. All right. So on the left side, I end up with a 9. Subtract that to the other side. And I have my -2y. So it looks like y ends up being a +3/2. Okay, so got some fractions, that's okay. Anticipate that. My official final answer then, as an ordered triple, would be -5, and then 3/2, and -1/2. Right, that is a nice ordered triple. Box that in. That's the point, or the point that would work in all three of those equations. Okay, here's an example where you would use a system of three variables where this might happen. It says here that the equation of a parabola is y equals ax squared plus bx plus c. Okay, we know that. But we also know that this parabola passes through these 3 points. We're supposed to find the actual equation of that parabola. Okay, so we can do that. Basically what they're giving us is a bunch of x, y coordinates. If you think of that as your x and y, and you have 3 of these, well, what I'm going to do is I'm going to take this point right here and plug it in for the equation of the parabola. So the y is 3 equals ax squared. So my x is 0. So that's 0 squared times a. Well, that's just going to be 0. Plug 0 in for the second x right here, and you'd have 0 times b, so that's gone. So really all you have left is c. Well, that's going to work out nice because basically they're giving you one of the points, or one of the variables. Okay, let's try the other points. They don't have zeros, not going to work quite as beautifully. So you have a y equals, so in this case it'll be a 4 equals, and I'm going to plug a 1 in for the x. So that's 1 squared times a plus 1 times b plus c. All right, and then the last point we plug in, and so this time the y is 3 equals, and then I'm going to do 2 squared times a plus 2 times b plus c. Okay, so we've got our system of equations, and this is kind of like that very first one we did where the c, or one of the variables, is given to you. So all I'm going to do is take this 3 and go plug it in for both of these c's, and I'm going to kind of simplify those equations up. So 4 equals a plus b plus 3, and I'll just subtract the 3 to the other side. All right, and then on my second equation, I'm going to plug in 3 equals 4a plus 2b plus 3. And then I'm going to subtract the 3 to the other side. And there I have another equation that has an a and a b in it. So I'm going to use those two equations to solve the system between a and b. So I'll have my 1 equals a plus b. Actually, let me erase that because I'm going to go ahead and change that. Let's go ahead and maybe take that times a -2, and that way we'll get the b's to drop off. Okay, so I've got, and I'm going to come over here and do this. So it's a -2 equals -2a minus 2b. And my other equation was 0 equals 4a plus 2b. Solve the system, you get -2 equals 2a, so then a would equal -1. And so now we know c, that was given, we know a, and so we just have to find b. So I'll take this a and this, and let's go ahead and we'll just plug it in to this first equation because it looks pretty easy. So then I would have a 4 equals a negative 1 plus b plus 3. Alright, so subtract that. B is going to end up being 2. Okay, so we've got the solution to the system. Now here's the thing though. It didn't ask you to find the ordered pair or that kind of thing. What they really want you to do is write the equation of the parabola. So the equation of the parabola goes back to this here, but we have to replace the a, b, and c with what we found. Okay, so then our equation will be, I'm going to write it way up here at the top, and it's going to be a y equals, and instead of the a, I'm going to put in a negative 1, or probably just a negative x squared, plus, and then I'm going to put in my b, which is 2x, and then plus 3. So that's the equation of the parabola that would go through those 3 given points. All right, we've got one more. Let's try one more application. And this one is actually out of your textbook, so take a minute and pause the video, turn to page 588, and read through 71. That's the one we're going to do together. 72, well, they're both actually on your homework. So if you want to just go ahead and get out a piece of paper to start your homework, you could just do 71 on that paper rather than doing it in your notes. So go ahead, pause the video. I'll wait for you. Okay, so here's what's going on. They give us a table of information, and this has to do with how fast you're driving and how long it takes you to stop, or what the distance is that it takes you to stop. So obviously the faster you're going, the longer you're going to travel before you get it stopped. But what kind of a relationship is it? This actually is a quadratic relationship. I've run across this equation different times, where this is a nice example where you would actually have a quadratic and the police would use this. Now, of course, they probably have a table or something that they're using, but that table is derived from this situation. So we're supposed to look for the quadratic equation that models this data. All right, basically same as last time. They're giving you 3 points. You write the system of equations and go solve it. So just not near as pretty of numbers, so I thought we might try this one together. So on your paper then, you've got this x and y, so we go back to that same quadratic equation, and so your y equals, and then it's ax squared, so 30 squared is 900, so that'd be 900a, plus 30 times b, plus c. Okay, and we just do this over and over with that y equals ax squared plus bx plus c. Next one, put in your y, and then you're going to have to take your x and square it, times the a, plus your x, times the b, plus c. And the last one, I got 188 equals 2500 a plus 50 b plus c. Okay, one thing that's nice about these types of problems is the c is generally pretty easy to get rid of. So here's what I think I'm going to do. I'm going to take this top, or I'm going to just do the middle equation. That way I can kind of group them easily. I'm going to just take it times a negative 1. So it's going to change every sign there. And then what I'm going to do is I'm going to go ahead and I'm going to group these two together, and then I'll group the bottom two together. So if I group these two together, I got a 55 and a negative 105. So that'll get me a negative 50. 900 and negative 1600 is going to get me a negative 700a. And then a minus 10b, and the c's drop out. All right, let's group these two together. So I've got a negative 105 with a 188. That's going to get me an 83. Equals, and then end up with a positive 900a and a positive 10b. Now you've got it down to 2 variables, and look how nice this is going to work out. 10's drop out. I don't even have to multiply by anything. So I've got this negative 50 and 83. So that'll get me a 33 equals a positive 200a divided out. And so it looks like it's going to be pretty ugly, but if you type that in your calculator, actually doesn't come out too bad. It's a 0.165. Not perfect, but it's a terminating decimal. Worked out okay. All right, so once you know your a, then we're going to have to plug it back in to one of these previous equations. I'm just going to take it into this bottom equation, and so then we end up with 83 equals, and I'll take 900 times 0.165, and I get 148.5. And then I still have my plus 10b, and I'm going to subtract the 148.5 to the other side. Still have my 10b, divide by 10. So b is going to be a negative 6.55. All right, so now we have b, we have a, the only thing missing is c, and so we can plug that back in to any one of those original three that we want to, and take the a and the b, and let's go ahead and plug them back into maybe just this top equation. It has the lowest numbers there, so we'll try that. So you're going to have 55 equals, and you take your 900 times 0.165, and I get 148.5, and then you take your b times 30, and up with a negative 196.5, and then plus c. Okay, so that actually comes out pretty decent. You get a negative 48 there when you combine those. Add the 48 to the other side, and I get 103 for my c value. Okay, and so part A asks you to write the equation of the quadratic. Okay, so here's what we would do is go ahead and fill in the a, b, and c into the equation. So this is basically your answer to part A on this. The equation would be y equals, instead of typing a, we're writing a, we'd put 1.165 x squared, and then plus the b, so that'd be minus 6.55b, and then plus your c, 103. This is the equation of the quadratic. Now part B asks you to graph the parabola and the data on the same set of axes. I'm going to go ahead and skip that. I'm going to trust that we did okay on this one, and that equation, if I were to put it in the calculator, it would actually go through those 3 points. But I do like part C here. It says use the model to estimate the stopping distance if the speed is 70 miles per hour. So you'd have to look at this. Oh, I just noticed that I put in a B there, and I should have had an X there. Sorry, my bad. Did you catch that? Hope so. Okay, so what I'm going to have to do here is plug in 70 and see what I get back. But the question is, do you plug 70 in for X, or you plug in 70 in for Y? Well, since they say that that's how fast I'm traveling, if you look back at the chart, the speed I'm traveling is the X value. So I'm going to plug 70 in for each one of my X's, and so you're just doing 0.165 times 70 squared, and then minus 6.55 times 70, and add in your 103. And it comes out nice. And so then this was the answer to part A here. So, and B we skipped, and so my answer to part C is 453. And then you have to think about what that means. What do you label that? That's my stopping distance. And in your chart, the stopping distance, actually you can't tell in the chart, but it says in the reading up above that the stopping distance is in feet. So it would take me 453 feet to stop if I was traveling 70 miles per hour. All right, so you can finish up. Go ahead and jump into 72. It's just very, very similar to this one. Or if you just want to go back to the beginning, work on your assignment for the rest of this. Good luck!